Hello, everyone. Welcome to the Interview Hub. If you're preparing for a PySpark interview, you're in the right place. In today's video, we'll discuss the most frequently asked PySpark interview questions, along with clear and concise answers. Before we get started, if you haven't watched our previous video on the top 5 most frequently asked PySpark interview questions, be sure to check it out. It will help strengthen your PySpark fundamentals and improve your interview preparation. Now, let's get started.
What is a wide transformation in PySpark? A wide transformation is a transformation where data from multiple partitions is required to compute the result. This causes data shuffling across the cluster, making it more expensive than narrow transformations. Key points: requires data movement between partitions, shuffle, slower than narrow transformations, creates a new stage in Spark execution. Examples of wide transformations: group by function, join function, reduce by key function, distinct function, repartition function. What is SparkSession? Answer: SparkSession is the entry point to programming with Spark. It allows you to create data frames, execute SQL queries, read data from various sources, and configure Spark settings. Starting from Spark 2.0, SparkSession combines the functionalities of SQL context, Hive context, and Spark context into a single interface. Example: from PySpark.sql, import SparkSession. Spark equals SparkSession.builder.appname myApp.getOrCreate. Here, Spark is a SparkSession object. You use this object to interact with Spark and perform operations such as common uses: read data, CSV, JSON, Parquet, etc. Create data frames, run SQL queries, configure Spark applications. What is difference between RDD and DataFrame? RDD is resilient distributed dataset. RDD is the fundamental low-level data structure in Spark. It is a distributed collection of objects spread across multiple nodes in a cluster. A data frame is a distributed collection of data organized into named columns, similar to a table in a relational database. RDD does not have a predefined schema, which makes it suitable for unstructured data. Data frames have a schema that defines the structure of the data. Yes, RDD is type-safe and gives developers fine-grained control over data processing. No, data frames are not type-safe in PySpark. RDD is the slowest among RDD, DataFrame, and Dataset because it does not use Spark's Catalyst Optimizer or Tungsten execution engine. Spark processes RDD operations directly, resulting in higher memory usage and less efficient execution. DataFrame is faster than RDD because it uses Spark SQL's Catalyst Optimizer and Tungsten execution engine. These optimizations improve query execution, memory management, and overall performance. RDDs require more coding and offer low-level control over data processing. Data frames are easier to use because they provide high-level APIs, built-in functions, and SQL support, which reduces code complexity and improves productivity. Both RDD and DataFrame support Scala, Java, Python, and R. This allows developers to use Spark in their preferred programming language while taking advantage of distributed data processing capabilities. RDDs are best for low-level transformations and scenarios requiring detailed control over data processing. Data frames are best for structured data processing because they are easier to use, require less code, and provide better performance through Spark's built-in optimizations. What is the difference between coalesce and repartition? Coalesce function is primarily used to decrease the number of partitions efficiently, while repartition function is used to increase or decrease partitions by redistributing data across the cluster by better load balancing and parallel processing. Coalesce function involves minimal data movement because it merges existing partitions. Repartition function redistributes data across all partitions through a full shuffle to achieve better load balancing. Coalesce function is typically used to reduce partitions after filtering data, while repartition function is used to increase partitions or redistribute data evenly across the cluster for better load balancing and parallel processing. What is the difference between cache and persist? Cache function stores data in memory using the default memory-only storage level and is used for simple caching. Persist function is more flexible because it allows different storage levels, such as memory only, disk only, and memory and disk. In fact, cache function is a shorthand for persist storage level.memory only. Cache function is less flexible because it uses only the default memory-only storage level. Persist function is more flexible because it allows us to choose different storage levels depending on memory and performance requirements. Cache function stores data only in memory using the default memory-only storage level. Persist function supports multiple storage options such as memory-only, disk-only, memory and disk, and serialized storage levels, allowing more flexibility in managing large datasets. Cache function is used for simple caching of frequently accessed data in memory. Persist function is used for advanced storage management when we need to control whether data is stored in memory, on disk, or using other storage levels. What is the difference between transformations and actions in PySpark? Transformations are used to create a new RDD or data frame from an existing one, while actions trigger the execution of transformations and return a result or output. Transformations define what needs to be done, whereas actions actually perform the computation. Transformations are lazy operations and are not executed immediately. Spark only records them and creates a DAG. Actions are executed immediately and trigger the execution of all pending transformations to produce the final result. Transformations return a new RDD or data frame, whereas actions return an actual value or result. Transformations define how data should be processed, while actions execute the processing and produce the final output. Transformations build the execution plan, known as a DAG, without performing any computation. Actions trigger the execution of that DAG and start the actual computation to produce the final result. Easy way to remember. Transformation builds the DAG. Action executes the DAG. Examples of transformations include map function, filter function, select function, and group by function. These operations create a new RDD or data frame. Examples of actions include count function, collect function, show function, and first function. These operations trigger execution and return the final result. Thanks for watching. Keep learning. Like the video, comment your questions, subscribe to Interview Hub.